Brad Williams, Frugal Finance. How about structured notes, the bear floater? This is going to be an inverse of the previous tutorial. Here, a bear floater is a floating rate note designed to allow the investors to profit from rising interest rates. Thus, the investor in a bear floater would be bearish on bond prices. Like an inverse floater, the bear floater can be issued as a standalone security with peculiar payoffs characteristics. Alternatively, the issuer may conceive the bear floater in conjunction with a derivatives position that gives the issuer a more conventional interest rate exposure. A bear floater is designed using a high floating rate less a fixed rate. Assume that the yield curve today is flat at 6%. In this environment, a bear floater might have an interest rate equal to 2 by 1 year SOFR 6%. With a flat yield curve at 6%, the initial yield on this bear floater would be 6%. This is the same rate that would prevail on a straight FRN, which would yield 6% in the environment. The special feature of a bear floater comes into play as interest rates rise. A straight FRN will have its yield rise in a 1-to-1 ratio with market rates. By contrast, the interest rate on the bear floater specified above would have to rise twice as fast as the market rates. For example, if 1 year SOFR rises to 9%, the yield on the bear floater would rise to 12%. If 1 year SOFR fell below 3%, the computed rate on the note would be negative. However, a bear floater will typically specify that the interest rate paid on the note cannot be less than 0. The issuer of the bear floater may simply issue the security and bear the interest rate exposure associated with rising interest rates. More typically, the bear floater will be issued in conjunction with a derivatives position as a structured finance transaction. The first timeline of figure 22.8 shows the cash flows for the bear floater, assuming a 5-year maturity with annual payments and a principal amount of $50 million. The issuer's annual payment is as follows: 2 times 1 year SOFR minus 6% times $50 million. Cash flows on a pay fixed swap. Here we are. Net cash flows. Here we are. It is convenient to think of the issuer's payment as paying 2 times SOFR and receiving 6% each year. If the issuer combines the bear floater with a plain vanilla interest rate swap, the issuer can use the ultimate form of its financial obligation. The second timeline of figure 22.8 shows the cash flow for a pay fixed plain vanilla interest rate swap. Here, the swap has a notional principal of $50 million, a fixed rate of 6%, a 5-year tenure, and annual payments. Combining the swap with the bear floater gives the issuer an annual interest rate cash flow equal to negative 2 times 1 year SOFR minus 6% plus 1 year SOFR 6% times 50 million. This complicated cash flow simplifies to 1 year SOFR times 50 million. So the issuer's exposure is simply that of a standard FRN. Third timeline of figure 22.8 shows the resulting cash flows for the issuer from issuing the bear floater and entering a pay fixed swap as just described. Therefore, we may analyze the issuance of a bear floater as follows. Decomposition of issuing bear floater, equation 22.9, issuing bear floater plus pay fixed swap equals issuing FRN. This analysis also shows how an investor can create a synthetic bear floater if the issuer wants to have the exposure inherent in issuing a bear floater. Synthetic issuance of the bear floater, issuing FRN minus pay fixed swap equals issuing bear floater. Or equation 22.10, issuing FRN plus receive fixed swap equals issuing bear floater. As we have just seen, the issuer of a bear floater can easily arrange for its ultimate exposure to be simply the issuance of a straight FRN. Similarly, the issue of a bear floater can use swaps to convert the exposure of that of a fixed rate bond. The first timeline in figure 22.9 shows the cash flows on the bear floater and is identical to the first timeline of figure 22.8. The issuer can use a pay fixed swap with a notional principal twice that of the bear floater to convert its total exposure to that of a fixed rate bond. In our example, the issuer would enter a pay fixed swap with a notional principal of $100 million, a 5-year tenure, annual payments based on 1-year SOFR, and a fixed rate of 6%. This cash flow for this pay fixed swap appears in the second timeline here of figure 22.9. These are just twice as large as the cash flows for the pay fixed swap here. The last timeline shows the result of combining the issuance of the bear floater with a double-sized pay fixed swap. The resulting cash flows in the timeline are just the cash flows from the issuance of a fixed rate bond. Therefore, we have a second potential decomposition of the bear floater issuance. Decomposition of issuing bear floater, issuing FRN, plus double-sized pay fixed swap equals issuing fixed rate note. This analysis also shows how an investor can create a synthetic bear floater starting with the issuance of a fixed rate note. Synthetic issuance of a bear floater, issuing FRN, minus double-sized pay fixed swap equals issuing fixed rate note, or issuing an FRN plus double-sized receive fixed swap equals issuing bear floater. What the issuer may synthesize, the investor may also construct. In the same market environment we've been considering, assume that no bear floaters are available and an investor desires the interest rate exposure inherent in the bear floaters. Based on our preceding analysis of the bear floater from the point of view of the issuer, we can see how the investor can create a synthetic bear floater. Equation 2210 shows how the issuer can synthesize a bear floater from an FRN and a receive fixed swap. The investor can create the same synthetic security starting with the purchase of an FRN by taking a position that is the opposite of that shown in equation 2210. Synthetic purchase of a bear floater, purchase FRN plus pay fixed swap equals purchase bear floater, or equation 2214, purchase FRN plus double-sized pay fixed swap equals purchase of bear floater. Brad Williams, Frugal Finance. Thanks for watching.